Hi everyone, welcome to our session Refactoring to Serverless. It's really nice to be here, to see many faces. And we are talking about serverless, so let's start with a question. Who of you has a serverless workload in production already? All right, I see many hands up. This is great because, folks, this session is really for you. For the other one as well, don't get me wrong, you can stay here. But we are talking really about serverless in depth and to make things even more serverless. I'm here together with Patrick Meiler, Solutions Architect.
Hello everybody, it's a pleasure to be here. And it's my honor to introduce Lucas Miller, Solution Architect Manager. And together we're going to talk about, as we already introduced, refactoring to serverless. Now what we're not going to talk about is how to modernize or migrate your application to serverless. Refactoring to serverless is all about leveraging, making your serverless application and refactor it to even more serverless. Now when I talk about serverless, it's more than just not managing infrastructure. It's more than just serverless compute like AWS Lambda. Serverless is the highest form of leveraging platform capabilities. And these enable you to gain more innovation, to be more agile, to gain more flexibility. And at the core of this is automation. Now, when we talk about automation, it's a concept that's been around for ages, obviously. It's evident also by this picture here. So on this picture, you see the Ford Motor Company, an assembly line roughly 100 years ago, where they produced the Model T. And what's so revolutionary about it is that it was an assembly line that made the whole manufacturing process much more efficient, much more cost efficient, and reduced the toil. The business impact was that the car was way cheaper than from other manufacturers. Now, you can order your Model T in absolutely any color as long as it's black. Now, this quote, and by the way, this is a real quote from Henry Ford, has some relevance today. Because when we talk about automation in the cloud, it's more than just the efficiency. Automating in the cloud gives us speed. We can deploy much faster. It gives us confidence. Confidence to deploy more repeatedly, faster. But automation also gives us transparency. Now, I can see thanks to automation, what happens in my infrastructure, how fast I deploy, how quickly I deploy, and I can even benchmark it. Another point of automation that enables us to is disposability. Let's say you want to try out a new feature, you want to experiment, you want to be agile, you want to innovate. If it doesn't work out, just get rid of it, and all thanks to automation. Now when we talk about automation, there's no way around talking about automation code or infrastructure as code. And infrastructure as code or automation code comes in different varieties. For instance, it's document-oriented flavor in JSON or YAML. Maybe some of you heard of Amazon CloudFormation or Terraform. Those are some proponents of it. But it's also functional languages, like in Haskell or F#. But today, at the center of it, we're going to look at object-oriented languages. Now, I'm curious, who of you already used AWS CDK, which stands for Cloud Development Kit? That's quite a few hands, and that makes me really happy. So I come from a developer background. I started as a backend Java developer. And when I started with infrastructure code and CDK, what was great about it, I was quite familiar with the concepts. The learning curve was not as steep. I could really get quickly done with the things in the infrastructure. Another benefit from using object-oriented language for my infrastructure or application is the ability to use concepts like classes and objects and have higher-level abstractions that I can reuse in different places. So what you see here, network load-balanced Fargate service. A Fargate service is a serverless container service, which is fronted by a network load balancer. We specified this with just 4 lines of code. In CloudFormation, we would need more than 450 lines of code for that. The other benefit of using object-oriented languages that we already know is the tool support that we know in our IDE, for instance. We can use linting, auto-completion features. We can use inline documentations. And that all enhance the experience of building infrastructure. Now, AWS CDK is compatible with various procedural and object-oriented languages. Obviously Java, but also TypeScript, Python, C# and Go. Another benefit of using the tools that you have at your hands and that you already know is generative AI support. So with Amazon Q, you can just ask Q, please generate me some infrastructure, generate me a load balancer. And quite quickly you can get results which even enhance your speed. Now, an opinionated architect would argue that cloud without the automation is just another data center. You may have heard of this today or not. But yeah, it's right. Our customers want the automation. They want to leverage the platform capabilities, our platform capabilities, to have more innovation, to be more flexible. And I consider myself also somewhat of an opinionated architect. I really like to deconstruct things. So let's have a look at automation and what it's all about. What are the components of automation? For one, it's the provisioning of infrastructure. In this case, we deploy a virtual machine where we deploy our application. Another component that we need to use is composition. How do these elements talk to each other? How are they glued together? And the last element here is configuration. Now, when we deploy our infrastructure in various environments, it's important to have the right configuration for the right environment. For dev, for test, for production. For instance, a database, for instance, some endpoints, and the log level. Now, this picture, it changes a bit when we look at it from a serverless perspective. For one, you don't need to take care of infrastructure anymore. Per definition, this is serverless, the absence of infrastructure. And deploying an application becomes as easy as putting a zip file into an S3 bucket. So what's left here is the composition and the configuration. So in a serverless architecture, how do our components talk to each other? What are the data flows? What are the control flows? And which granularity they talk to each other? Do they talk asynchronously, synchronously? Those are the relevant questions. And when we think about configuration, we really need to think about what is the application logic? What do we configure? Which managed services do we configure? What are the message formats? What is the contract that we have between our components? So, with that in mind, infrastructure as a code, from a serverless perspective, becomes really application architecture as code. And thanks to CDK, it really becomes application architecture as actual code. So I would say, let's have some examples here.
Having now our application code on one side, automation code on the other side, and maybe even both in the same language really provokes the question, right? Can we maybe replace one side with the other? Can we maybe even move some of our application code to our automation code? And well, this somehow sounds familiar, right? We are talking here about structure of code, and this is nothing really new for anyone who has ever done application development. The term refactoring has been around for ages, and Martin Fowler really wrote a book about it around 25 years ago. And folks who are familiar with test-driven development, they know this is a continuous habit. In test-driven development, what do? We have an idea in mind that we want to implement, so we start with writing a test, and this test will fail, right? It will be red. The next thing is we want to write just enough code to make this test green. This test needs to be green without that we have to have beautiful code, right? This code just needs to do its job. And the third step is crucial because otherwise we will have like really a mess, right? We need to improve the structure of our code. And this means we need to refactor. This is really what refactoring is about. We want to replace our variable names with something that is more meaningful, maybe switch methods around, create some new objects, whatever helps us to understand the code. But one thing is crucial, and this is we don't want to change the behavior of the application. We don't want to break our existing tests, and we also don't, and this is actually really tricky, we don't want to introduce new behaviors that we hadn't had before, because they would be not under test, right? And this is really the tricky part of it. We want to use this mental model for our serverless world. And you will see this somehow works. It is actually really helpful. And we want to define serverless refactoring as a technique to replace our application code with automation code that has an equivalent behavior. So let's take a look into one example here. We have here a very, very simple Lambda function, right? It does some business logic. What exactly doesn't really matter, but it has, in the end, a result. And we want to use this result for something, so we need to write it somewhere. In this case, we decide to send it to an SQS. So here is the question: what is wrong with this code? Right? It's a trick question, I will tell you. Right? We don't like trick questions, and because this code works perfectly fine, you can do that, right? However, here are two catches. The first one is we have a reference to our SQS inside an environment variable. Now we are talking about distributed systems, and at some point we need to bring it to production. This means we need to operate it. And imagine now you need to monitor it or to troubleshoot it. You need to follow this environment variable. You can do this, of course, right? But it's annoying. And the second thing, I think this is even more important, we are mixing two things here. We are mixing our business logic with our application topology. If you now want to replace the SQS with something different, let's say an SNS, you need to touch this code. And this is something that we actually can avoid. Because in serverless environments, we have a choice. What we can do instead is we can use Lambda destinations. With Lambda destinations, we have a feature at hand that allows us to decide on runtime where we want to write the result. And we can choose between SNS, SQS, another Lambda function, event bridge, event bus. All we need to do is we need to touch the automation code, right? And this gives us multiple effects. The first one is we have an actual reference in our code, in our automation code, for our queue. So we have no need for following any environment variables any longer. The second thing is we actually reduce the runtime of our application code. And this is a big deal for Lambda, right? Because this is actually tightly coupled to costs. So with this refactoring, we also change the runtime characteristics. This is a small example, but we can even think about a bigger one, right? And let's take a popular example, a simple booking application, and we want to somehow allow our users to book a driver, right? It's a well understood problem. We heard even this example today before, so we can use it again just with a different architecture. In this time, we have here 3 Lambda functions, and they represent our whole application. The first one just takes really just a user interaction. The second one handles the payment, and the third one assigns a driver to one of our users. So all these Lambda functions have some downstream systems they interact with, but what is really interesting here is how do these Lambda functions talk to each other? So how do they choreograph themselves, actually? They are all sending events to event bridge, event bus. And again, this is an architecture that works perfectly fine. It has actually very nice properties that I would like to have, right? It is very flexible. It is very scalable. I can just use these events that are coming in to drive new behaviors. I can have additional Lambda functions. I don't need to tell the other Lambda functions that something changed somewhere in my application, so I can also scale them independently. I can refactor them independently. That's pretty nice. However, we have here 2 catches that we need to be aware of. The first one is the Lambda function needs to participate in our application topology. There's no way around, right? This is just how it works, because we need to tell the Lambda function somehow, either with Lambda destinations or in our code, that we need to have an event. That's trivial, but it's important to say. The second thing is we actually will struggle with keeping transactional integrity. Imagine now in this workflow, the payment service goes down or is unable to send an event. Then we need to think about how do we handle this error. Well, we can do this, right? We have a lot of smart engineers in our teams. We have library supports, and we can do this, of course. But it will require us to have another piece of maintenance in our hands, in our responsibility. And actually, we have a choice. We can do this differently. We can use step functions to move this to an orchestration pattern. With step functions, we can define exactly in which order do we want to execute our Lambda functions. We can say, okay, what happens in an error case, right? What do I do in this situation? And even, I think this is actually pretty exciting. We can push some of this heavy lifting that I talked about, like retries, like timeouts, to the platform. We can make use of platform capabilities in order to do the heavy lifting. And as a side effect, we also gain a better perspective on our distributed system, because we now get really an overview about what is happening in our distributed system. So now I could tell you this is just better. But of course this is not true, right? Because architecture choices are all about trade-offs. The left side has just different properties than the right side. And it is important that we understand the trade-offs and we understand what we choose. So what are the trade-offs here on the left side? Actually, first of all, we get kind of a tight coupling, right? At least a little bit, because now all our Lambda functions need to be known by the step functions. And every time we change our application, we also need to touch step functions. This can be a good thing, a bad thing. It really depends on your needs, right? If you want to have this level of control, this is great. If not, it can become a bottleneck. So there might be even situations where you need to do the reverse, where you need to actually want to refactor from the left side to the right side. This is okay, right? We are not saying this is wrong. We are just saying that the difference is here really in the details. I have a third example that also speaks about coupling, actually. And it comes with a very, very simple pattern, actually, but it's interesting. We have a Lambda function that reads and writes to a DynamoDB, right? Just simple database interactions. And every time we make a change to our database, we also want to publish an event and bring it to EventBridge. And by now, you know the trade-offs, right? We went through them. We can even say them together if you want, right? We see what are the trade-offs. The trade-offs are, we have here a mixture of application topology and business logic again in our Lambda function, because the Lambda function needs to participate in the flow. This can be okay, right? But even more important again here is the question, how do we ensure transactional integrity? For a database, honestly, this is something our application development teams know how to do, right? They know how a retry works for a database. And also, if the event fails, we have some options. We can think about, if we cannot send the event, to retry sending the event. We can think about undo the database write. This is all possible. However, this is hard, right? Because we need to code this, and we need to maintain this, and we need to take care of it. So, and again, we actually have a choice to do this differently. We can make use of another feature and of another service. With DynamoDB streams and with EventBridge pipes, we can transform this to an architecture that looks like this. So DynamoDB streams offers us actually an event stream of everything that happens in our database. And we can consume the stream from another point. And in this case, we can make use of EventBridge pipes. I'm actually a very curious person. We introduced EventBridge pipes in 2022, and I would love to see who tried it already out, who gave it a try, EventBridge pipes. A few hands only. Okay, I expected more excitement, because I find it very exciting, actually. So give it a try, because what you can really do here is you can directly connect a producer of event to a consumer. And you can decide on the way which kind of events do you want to pass through. You can filter them. And this is also important, you can actually transform them on the way. Let's take a look into our code, how it changes, right? We will just take a look into our application code, but here we have actually the one important line where we put something into our table. This is the real thing we want to do. And then we need to decide somehow to publish an event. In this case, we do it directly in our code. And after the refactoring, well, it looks actually quite nicer, because we have only really one line that we say we want to put something into the code. And we saw already the trade-offs that we made before, right? We have now transaction integrity that we had difficulties to gain before, and we can actually think about changing our destination without touching the code. However, I again don't want to tell you that this is just better. We are introducing here another feature, another service, and for the ops folks of you, this will ring some alarm bells, and maybe also for the cost folks, right? Because you might want to think about, what does it now mean for my operations? What does it mean for my costs? What does it mean for my latency? And to give you one example, for instance, one thing that we need to think about is we actually kind of couple now our event format to DynamoDB. Right? Because every time we send now an event, it is actually in the way written how DynamoDB publishes this event. we don't control this any longer. With pipes, we have a choice to actually transform the message to any format that we would like to consume. But again, we need to maintain here a different piece of code. So it's really about trade-offs. And I would love to, and I will actually, dive deeper with you into the operation aspects of these kind of choices, and also in the cost and latency implications. However, first, let's gain an overview about all the different refactorings that we can also think about if we are in the serverless landscape.
So these refactorings, these patterns that we saw, we didn't invent them. Those are customers that are actually using them for various reasons. Now, before I start to map those reasons or the patterns to the reasons, let's go quickly to why our customers actually do this. For one, customers want to leverage platform capabilities, our platform capabilities. They want to use the features that are available to automate faster, to innovate faster, to be more agile, have more flexibility. But our platform evolves. We don't have the same set of features as we had last year. In fact, last year we released over 3,000 new features and services. And that means that our customers have now more chance or more choice to actually automate their infrastructure, to leverage even more. Now the thing is, okay, what if the application grows? What if the application goes more complex? Well, there might be the chance that a new requirement doesn't any longer is met by the managed services. So what happens there? It's completely valid to go the other way around, to remove the automation code and insert it back into the application code. That's also a valid choice. When we talk about improved runtime characteristics, we saw that by removing elements out of the Lambda, we make it faster. There's less code to execute. We saw patterns, or we saw examples where we get rid of the Lambda completely. So that's absolutely improving the runtime characteristics because it's not there anymore, of course. And then there's also the reduced complexity and the reduced cost. And cost have two dimensions here. For one, okay, we get rid of our Lambda. We get rid of the application code. The Lambda runs faster and is more cost efficient. So the financial aspect is reduced. But then there's also another dimension. Let's say you have a team that has to maintain a lot of application code. And when you reduce the application code, or when you remove the application code, it decreases the complexity because the team doesn't have to maintain it anymore. You don't have to have a team that's dedicated for maintaining the code. And when that happens, your team is able or empowered to innovate. They have more time to do other things that have actual business impact. And that's what we call opportunity costs, the costs of sunken opportunities. Now, let's go through the patterns that we saw and map them to these motivations. And those are just dimensions that are not exclusive to each other, so there can be an overlap. We saw how, in Luca's example, we shifted application code from the Lambda to automation code by using Lambda destinations. So instead of actually calling the SQS from within the code, we shifted it to the CDK through automation code. Another example was how we leveraged DynamoDB streams and event bridge pipes to actually also leverage the platform capabilities there. But as I said, our capabilities evolve and we announce new features. So let's have a look at this part. So imagine you have a case where you need to use a large language model and you need to use generative AI for a complex flow, how you process your documents, and you have to orchestrate it somehow. Of course, there's the possibility that you can call the large language or Bedrock, Amazon Bedrock directly. But we, at the last reInvent, we announced the feature to call it directly from step functions. So you have now the possibility to orchestrate your whole complex business logic and call Amazon Bedrock directly from within step functions. Another example of this is DynamoDB. The same flow. You have a complex business process where there are a lot of branches, and step functions gives you the ability to map this out visually and also use direct DynamoDB integration. Now, step functions offers more than 200 optimized service integrations, and those are just examples. So, again, what happens when your application code evolves and your requirements are not met by the services anymore? One example could be that you have a really complex event pattern that you somehow need to match, and it doesn't work anymore with managed services. It doesn't work anymore with automation. So the possibility that you have is to write it back in your application code. When we talk about improved runtime characteristic, we saw an example of AWS step functions that Lucas showed, how to actually map try-catch flows. Another example is if you have, for instance, a Lambda function that pulls something from your event source, you can just use a wait and callback mechanism from step functions. Now, we are all architects here. We are all evaluating trade-offs. We all have to look at the bigger picture. And Lucas showed a great example here of moving choreography to orchestration. The other way around is also a valid and possible approach. And the baseline is here, or the message here, you have to look at the bigger picture. What makes sense within the context of my business, of the business value that I want to deliver? How are the elements glued to each other? What is important to me? Is it transactional integrity? If it's transactional integrity is important, then of course go ahead with step functions and orchestration. If that is not a concern for your application, EventBridge is the way to go, and decouple your services from another and have much more flexibility. Now those are the patterns. Those are some patterns that we saw from our customers mapped to the dimensions. And now let's have a look at some operational aspects of what is actually the impact of all those refactorings.
I really like the idea to zoom out a little bit. And if we do this, right, then we can go back to our start. We said we are using really the mental model of application refactoring. And in application refactoring, it is so important to us that we want to preserve behavior. And we can now really discuss, well, do we really do this? Because we are not just touching one code base, right? We are talking here about a distributed system. And in fact, I have to admit, it is not always the case. Actually, there are important nuances that we need to be aware of. And I want to just give you an example. Let's move back to our first example, right? We had a Lambda function. It wrote something directly into an SQS. So we send message and put it to Lambda destinations. The first thing that we need to be aware of here is we have two options to call a Lambda function. We can do it synchronously or asynchronously. And this refactoring will only work if you invoke it asynchronously, otherwise not, right? The second thing that we need to be aware of is with destinations, we actually wrap our payload inside an envelope. And, well, we need to make sure that our consumers are also unwrapping this payload again. Otherwise, our system might break. This is super important. And this is an easy thing to do if this whole refactoring is owned by one team. But imagine you have multiple teams involved here, then you will make sure that they know about this change, because otherwise you might break their code. And the third thing is, I think this is a nuance, but I think it's an interesting one. We send the message now as a result at the end of our execution time with Lambda destinations. And why is this important? Well, think about a case. Maybe you write a Lambda function, you decide as first step you send out an event, and then you do some very expensive computation, right? It takes a while. Now you will see some latency increase. If you have such a case, then you might want to think, is this really the best architecture, right? Maybe, maybe not. But maybe you're super sure and say this is the right thing to do. Then you can actually at least mitigate this by splitting this into two Lambda functions. Well, all these trade-offs, however, they give you what we are looking for, and this is a higher resiliency and transactional integrity, right? You just need to be aware what it really does to your distributed system. Okay, we have now an idea about some operation nuances. Let's take a look what happens to latency. And I would love to take the third example here, where we used our DynamoDB streams and EventBridge pipes to refactor our application. And our colleague Gregor Hoppe, who had a talk earlier today, made some nice experiments around this, right? And what we can see there is that we actually see an increase of latency. Why is that? Well, it makes totally sense. DynamoDB streams is now consumed by EventBridge pipes, and EventBridge pipes is using polling. We have here now some possibilities to actually configure that, right? We can think about what kind of batch size do we want to use, which frequency do we want to poll. However, we will see a latency increase. always looking at the bigger picture, Patrick's advice makes sense here as well, because we already saw that we actually also changed the runtime characteristics of our lambdas. So we will save some milliseconds in our lambda functions. So around 40 in this example, right? So it's important to see the bigger picture. And one thought more, if we have an event-driven architecture, we usually optimize for throughput, not for latency. So this might even not bother us at all. Let's talk about costs. And we stick to this example, right? We are introducing here a new feature and a new service. And if you present this to your product owners, then they will probably say, what are the costs, right? And you will say, it costs more. It costs 40 cents per million events if we introduce here event bridge pipes. But again, it makes sense to look at the bigger picture, because we save execution time in the Lambda, so we will actually save you some bucks. We are not doing your cost calculation here live on stage, right? This is not your environment. You are in a different region. You will have a different payload. You will have a different properties. So this is these are reasonable assumptions, but this is not your workload. The message here really is, it makes sense to look at the bigger picture instead of trying to find the local optimal level for one service that costs something. And it becomes really interesting if we consider that we have the possibility to directly connect a consumer and producer of events with event bridge pipes. So we might think about, do we really need event bridge, event bus in the picture at all? Because if not, we actually save $1 per million events, and we are very much in the black. This is great, right? Then we have even here a cost optimization case. So with this in mind, it's always important to look at the bigger picture. I will keep saying that. This is really the main message here. And one more thing, right? If you are not having Prime Day or Black Friday, then you could say serverless is relatively cheap. So just introducing a new service is something that can save you many developer hours, because maybe you are able to catch a bug earlier, maybe you can do your troubleshooting faster, but maybe your coding becomes more straightforward. And one developer hour can be worth easily 500 million of events, right? So it is really important also to think about the total cost of ownership here. So now you can say, and I think this is actually totally fine to think, now I'm telling you, right? You need to think about the operational aspects, you need to think about latency, you need to think about costs. We have the whole catalog of different refactorings. This is a lot of work. So this is like a lot to consider. And the question is, do we really want to do this all the time? Or is this a one-time off thing? Or how do we do this really in our teams? Well, I think one thing that we learned over all these years is something that we learned from deployments. If you do a deployment once a year or every half a year, this is gonna be really painful. This will give us a few very bad days, right? So we will hassle around some bash scripts and so on. And again, Martin Fowler helps us here with some wisdom. He says, if it hurts, do it more often. And we learned this in our deployment pipelines. We are doing continuous integration, continuous delivery, continuous deployment, all those nice things, because we know if we do it more often, then we have enough automation around it so that we feel confident. Again, a keyword here, that we can pull this off all the time. So how do we move this to refactoring? Again, this is nothing new, right? I'm not telling you something new. Refactoring is part of software delivery for your application development teams, and we think this should also be true for serverless refactoring. And if you still think, well, this is really hard for us, then there might be good reasons for them. And some of them might be, for instance, missing test coverage, right? So if you say, I'm not sure how this really affects my latency, maybe you are missing the monitoring for the latency. And maybe this tells you something about your visibility into your system, something that is actually really important. But if you do this, then you gain really two capabilities that can become a habit for your teams. The first one is you can really think about, how can I move complexity? Because, right, we all know complexity over time has only one way, and this is up, right? There's no way to really reduce complexity in a meaningful way. So we need to think about, what do we do with this complexity? And sometimes we'll have a choice to actually push this complexity into the platform. We want to make use of it. And sometimes not, right? We heard about these cases. Maybe the platform has not the capabilities I'm looking for. Well, then I can at least use my automation code to make my complexity more manageable. So also this gives me a better leverage to actually keep my velocity high. With this in mind, we see that the lines here are really blurring between different job roles, because automation is something that, well, our DevOps engineers know very well, right? Our site reliability engineer teams, they know how to automate stuff. But we are not really in the sphere anymore here, right? We are talking here about application code. We are talking about something that is very integral to our just software delivery lifecycle. And I'm sure that all these different job roles, they have different perspectives on the systems. However, using automation or not using automation is not the distinction here. Automation is relevant for all of them, right? And actually this becomes then a challenge, because if we now do these kind of refactorings, the question is really how can we streamline this with the different job roles that are involved? Because if you need to cut a ticket every time you want to change the Lambda destination, this is probably not the way to go to stay really fast, right? Then we will not have the velocity that we are looking for. So what we saw, for instance, is that these kind of refactorings work really well if they are happening in one team context. And I think this is another dimension we really need to think about here, right? These refactorings, they are not just happening in a perfect space. I think the main message, however, for all those teams involved is refactoring needs to become a continuous habit. It's not a one-time off activity, and I will say, well, now go refactor, right? And now you say, okay, this sounds nice, we will do this, but where do we start? And I saw many of you making some photos of our service catalog. I think that's a great start. Actually, we created a website, and if I say we, I need to be precise, it was our colleague Sindhu, and she created this website. It's called Refactoring Serverless, that really contains the whole catalog. So I'm asking you to go to this website, to make a screenshot of this slide actually, to read it with your teams, and to think about what are the refactoring patterns that we can use today. What are refactoring patterns that we might want to have on our radar that will help us, hopefully in the future, to improve our operational capabilities. And with that, I only can say thank you so much for staying with us and to attend the session.
And of course, reach out to us if you have any questions regarding serverless, regarding automation. Here are our contact details. Make sure to contact us. We're happy to look at you, and help you. And yeah, we're going to stick around for a couple of minutes here. So if you catch us, go and feel free to ask us some questions. With that in mind, I can also conclude. Thank you very much.